Hi, today I'm going to show you how to perform the difference between ARCH, GARCH, TARCH, EGARCH and MGARCH, which is multivariate GARCH model using eViews 10. What is ARCH model? ARCH is a method that explicitly models to change, the change in variance over time in a time series. Specifically, ARCH method models the variance at time step as a function of residual errors from the mean process, which is namely equal the mean 0. Then why ARCH model? The classical theory and assets pricing model assume volatility is constant over the period. However, most of the financial data, any one of or more of the following feature: volatility, clustering, sometimes volatile, while other low or less volatile. Big shocks or residual tend to follow big shock in either direction, and small shocks are follow small shocks. This is apply a strong autocorrelation. There are a period in which the variance is relatively high. Such series are called conditional heteroscedastic. ARCH model are highly useful in many situations where the prediction of volatility is important. For example, asset holder want to forecast for mean and variance of return. Now, here we move to the steps. We have many steps to forecast these models. First, we run the regression. The variable R and RS, which is return and stock return. C and AR autoaggressive as ordinary square. Second, we draw the graph from view, run the diagnostic. ARCH, we look at the observed R square corresponding to p-value. P-value less than 5%, meaning that we can reject null. What is null? Null is there is no ARCH effect. So if p-value is significant, indicates significant clustering, low volatility clustering. In this case, we have to go to GARCH model, which means that the ARCH effect is present in the model. In this case, the regression model is not good. Then we have to run ARCH effect model. And this is the equation or the model. Variance, present time, intercept, which is the mean, return, and this is the residual lag 1 period square, which is variance equation in ARCH model. Then we have to interpret the ARCH effect model. In ARCH we don't bother about R square. If p-value is less than 5% significant and reject null hypothesis, then we will go to apply the ARCH model because the ARCH effect is present in the data or in the model. So what is GARCH model? GARCH model is generalized autoregressive conditional heteroscedasticity, is an extension of the ARCH model that incorporates a moving average component together with the autoregressive component. Specifically, the model includes lag variance term, namely the observation of modeling the white noise residual error of another process, together with lag residual error from the mean process. As such, the model introduces a new parameters, which is P, that describe the number of lags variance term. P, number of lag variance include GARCH, and Q, the number of lag residual error include GARCH model. And this is the GARCH model equation This is ARCH, and we added the GARCH model here, the variance square lag 1, and then we have to move to TARCH model with dummy variable, and this is the equation, and this is the dummy variable term. If this one 0, this means that we are looking for GARCH model. But if here the dummy variable d lag 1 is the variable which has the value of 1, if the residual lag 1 less than 0, which is negative. Otherwise 0 capture only negative news, which is positive. Okay. How? This is the hypothesis, null hypothesis, sigma here. As you can see it, this is theta. Bad news equals 0. Bad news not increase volatility, and if theta is positive and significant, bad news bring more volatility. Then we move to exponential GARCH model, EGARCH model. And EGARCH model, this is proposed by Nelson 1991, and this is, we have to use the log variance, lag 1 in the last period, previous period, and here you can see this is theta. If theta is negative coefficient, it means there is no leverages effect, and the leverage effect takes the following: bad news has more impact on volatility than good news. Volatility is higher in falling market than in a rising market. Non-trading period effect: when market is closed, information ceases to accumulate at different rate to when it is open. This is, we are going to explain it when we use the views and with the interpretation of the outcome. And finally, we apply multivariate or MGARCH model, and this is the equation here. We are concentrating on the B3 coefficient. B3 coefficient, this is the MGARCH model. Then we will concentrate on B3 or beta 3 to see whether there is impact of the variance of volatility on the return RT, significant or not. If p-value of beta 3 greater than 5%, then there is no significant relation between the variance, which is this one, and between the return. So there is no relation between variance and the return if it is not significant. And this is we called multivariate GARCH model. Okay. Now we'll go to the view. We open the data, and this is the data here. Open it as a group. Then we have to run the regression. Go to quick estimate equation. The dependent variable return R, constant RS, stock return AR1, which is autoregressive, and let me add MA1. Okay, this is the equation we are going to perform to use all the GARCH and ARCH family models, and we'll see what is the difference between them and when we can use each of these models. Now we set up the variable, we run the regression, we use the ordinary least square as you can see it here, then I press OK. This is the model, which is ordinary square model. We are not interested in the outcome of this model, just we want to go and draw the graph for the residual to see whether there is any volatility clustering in the model or not. I'll go to view, actual fitted residual and residual graph. Here you can see, as you can see it here, we made it clearly. Here you can see the volatility clustering. This is a clustering, which is fluctuation when large change or high change, as you can see it here. Okay. When there is volatility high sometimes, and volatility is less sometimes high, sometimes low, and or we can say if the volatility, as you can see it here in the outcome, clustering when large change, as you can see it here, large change here are followed by further large changes and period of small changes followed by period of small changes. So from the growth one can see there is a wild, as you can see it here, and calm period, and this is the mean, the constant, as you can see here, the mean with 0, as you can see the mean is 0. Then in other words, volatility high sometimes and volatility is low sometimes. This means that we have low and high volatility at different time. Then we can see there are different cluster, high and low, wild and calm volatility clustering. So after we test the graph, we have first to go to test the diagnostic of ARCH to check whether the volatility clustering exists in the data or present in the data or not. I'll go to view, residual diagnostic, heteroscedasticity, and select ARCH, press OK. Here you can see the observed value of as you can see it here, observed R-square corresponding to p-value of chi-square less than 5%, which is significant, which means that we are going to reject null hypothesis. What is null hypothesis? Null hypothesis, the model has no ARCH effect present or no volatility clustering, and alternative there is ARCH effect is present, which is the ARCH effect include the model, which is present in the model. Now in this case we can see here the dependent variable residual, as you can see it. The dependent variable is the residual square, whether can be predicted by residual square lag 1 or not, as in the above, as in this outcome. So the p-value of residual square lag 1 is positive and statistically significant, which means that there is a significant volatility clustering residual. So the model here, the equation we have, as we mentioned earlier, this is the equation here. First equation, this is for ARCH. You can see it here, and this is represent alpha equal here in the model. Okay, just let me minimize it a little bit to show you from the outcome. Okay, so here the ARCH effect, as you can see it, ARCH model, this is residual lag 1, this is the residual square, this is here, and here the constant, as you can see it, C is 0.000076 plus, beta is for residual square lag 1 0.131, and the p-value is less than 5%, which is statistically significant. So this is the estimating or the arch model. We found that arch effect is present in the model, therefore we have to go to the GARCH, and then before that we have to run arch model. I'll go to view, sorry, I'll go to estimate, I'll go to arch, then we estimate arch, we put 0 instead of 1, and we leave option, we use the EViews legacy and leave everything as it is. I'll go to specification, press OK. This is the arch effect model. As you can see, the residual square lag 1 is positive and statistically significant, and the dependent variable is return. This means that we can see the residual lag 1 square positively if influence the return and statistically significant. So in this case, arch effect present in the model. So we look at the variance equation. As you can see it here, this is the equation and this is the variance equation, and we find it that significant, statistically significant, and the model is present in the data. Then we have, as far as the model is present in the data, we have to go and apply for GARCH model. So in this case, I'll go to estimate, I add here 1 for GARCH, arch 1, GARCH 1, and there is 0 here, leave everything as it is, press OK. This is the outcome. As you can see it here, we have the variance equation, and this is the mean, the constant, residual lag 1 square, which is the arch term, and GARCH lag 1, which both of them, they are statistically significant, and the dependent variable return, which is R, and then the alliteration 23, and this is the outcome, probability greater than 5% in the mean equation, because we are not going to delete any of these variables, mainly because we are talking about variance equation. We are concentrating in variance equation, and in variance equation, as you can see it here, in GARCH model, this is GARCH model, and this is C, which is alpha here, alpha 0, 0.00007.76. This is for alpha 1, alpha 0, and then for the arch term, which is residual lag 1 square, 0.048, 0.048 lag or residual lag 1 square. And the GARCH model term, and GARCH term here, you can see GARCH lag 1, the coefficient is positive 0.942, and statistically significant, this is beta 2. And here we have to look at the main differences. So when we get this outcome here and the interpretation of the outcome, as you can see it here, this is here beta 1, as you can see it here, beta 1 plus beta 2 goes to 99, something 0.99, which is less than 1. And beta 1, which is residual lag square for arch term, is 0.048, and the beta 2, which is this beta here, as you can see it here, equal 0.94, which means that beta 2 greater than beta 1, and the remaining we call it the decaying rate. Okay, so when beta 2 greater than beta 1, this means resistance, meaning that the market remain off for more or some days or weeks or months or without any reason. So decaying rate is 0.09. How we get it? Here we can say 0.991 both of them B1 plus B2, and the remaining we call it decaying rate, which is 0.09. And this is the simple explanation, the GARCH model. Here we can add, so the resistance mean that if the market remain off for some days without any reason, even if positive news come tomorrow, the market remain volatile, like corona virus. You can see there is no decreasing, but it's still coming slowly, but the market is still volatile. Even we have the information, but the market is still volatile, very high. Suppose you do not want to apply GARCH model, only you want to apply ARCH model, then you have to apply ARCH model. First you go to GARCH model, and then you apply for the ARCH model. Then for GARCH model, if the result of GARCH model is not sufficient, let me say, put it here, just now, if GARCH model outcome is not sufficient, as a result, we have to go to TARCH model, and then TARCH model applied with dummy variable. So here, what is the dummy variable? The dummy variable is positive, which means the error term. If the error term positive, which is 0, giving the value 0 with bad news, and error term negative, given the value 1. So what is the equation of the GARCH? We'll go to the note here. We can see the GARCH here. Let me see it here. Yeah, here it is. Here, TARCH model, as you can see it here. This is the TARCH model. Just I want to put it here in case of we do some interpretation. Okay. And this is here. We'll go to test for TARCH model, and this is the equation here, as you can see it. This is the equation for TARCH with dummy variable lag 1. So variance squared present, constant, the ARCH term, residual lag 1 square, and GARCH term, residual variance lag 1 square, and this is the dummy variable. Of course, if these equal 0, so we delete this part, we are talking about GARCH model only. But if this term is not 0, so it means we have to talk about the TARCH model and to see the dummy variable whether has an effect on the variance or not. As you can see it here, this has the value 1 if residual lag 1 less than 0, which is negative, otherwise equal 1, or otherwise equal 1, only negative news, which is positive. So let me go to eViews. Let me go to the eViews, and then we explain the term of TARCH model. I'll go to estimate, go to estimate, and then this is the equation for GARCH. We add only here 1, as you can see it. This is, we are using TARCH model, so in this case we have to leave as it is, this one, and then we have to run this model with the same variable, and we'll see. Okay, so here what we have now: ARCH1, GARCH1, and threshold order 1, which is TARCH model. We leave everything as it is, and then I press OK. This is the outcome of TARCH model, and this is the variance equation which we are going to concentrate in this variance equation. So what is this? Let me state the hypothesis for TARCH model. The hypothesis is, if, let me see this part here. The main thing is theta here. If theta equals 0, it means bad news. Want me to put it here in the command. If theta, let me just copy it. Copy. If paste. If theta equals 0, bad news, more impact on volatility which is not increase which is not increase volatility. And if theta is positive, bad news, bring more volatility or volatility is asymmetric. Okay, but if theta negative, it means more impact on volatility. So now we run the model, we got the data. Just I want to explain the data here and the outcome. According to the outcome here, we have it. This is the equation and this is the outcome. Okay. Now in the outcome you can see the constant statistically significant. All the variable is statistically significant, and here we can say the alpha 0 equal 0.70604, and beta for the arch term beta 1, which is this is residual lag 1 square arch term, is 0.0132 positive and statistically significant. And for arch 1 lag 1 you can see it 0.955, and this is here in the equation, this is B2, which is arch GARCH term or residual GARCH lag 1. So this part here, residual square lag 1 square multiplied by residual lag 1 less than 0, which is this one here, this part here, and this part here. This is theta. You can see it's positive and statistically significant. So here, what does it mean, this? As we mentioned earlier, we said here C5, C1, C2, C3, C4, and this is C5, C6, C7, C8. We have 4 here, and here we can look at it. C5, this is C5, C6, C7, and C8. We have to interpret this. C5, as we mentioned, C5 here, the constant, and C6, as you can see it, residual R square, residual lag 1 square arch term, and C7 here, which is B2, C7, here we can say it GARCH lag 1 period square, which is GARCH term, and C this one here, C4, C5, 6, 7, 8, and C8 here. C8 represent the positive and statistically significant. This is must be less than 0. Then we can assign the value, and this is the, we call it the sigma arch. This is, we call it sigma here, residual lag 1 square, which is this part here, residual lag 1 square, and the second part multiplied by residual lag 1 square here, less than 0, which is negative. If the coefficient is positive and significant, this means that the dependent variable R, as you can see it here, this equation R, the dependent variable R reacting more to bad news and less to good news. In other words, if theta positive, as you can see it here, if theta here, theta positive, as you can see it here, positive and statistically significant, so the impact of negative shock on volatility is statistically or significantly higher than the impact of positive shock on the volatility. Okay, so in this case, this is positive and statistically significant. When we say positive, it means that the dependent variable are the return reacting more to bad news and less to good news. And this means that the coefficient here positive and statistically significant. So in this case, now when we are going to apply EGARCH model, so if we get negative autocorrelation or sigma variance square present negative, this is against, which means this part here, just to show it to you. If we get this one negative, which is I1, I1 and I2, or B1, this one and this one here. If we get it B1, B2, if we get it negative autocorrelation and sigma square at the present, which is the dependent variable here, negative, this is against the logic, then we will go to apply EGARCH model. What is EGARCH model? EGARCH model, which is exponential GARCH model, was developed which take logarithm, log, form of conditional variance equation. So exponential GARCH model proposed by Nelson 91. So what is the formula we used here for this? Is the GARCH model. This is the exponential GARCH model. We use the lag here, a log, as you can see it here, and we have two terms. This one, the absolute term, and this is the. So what is this? Let me just do some interpretation of this form. So we find that to find the leverage effect, if theta, as you can see it here, the last one here, if theta negative coefficient, it means that, let me just put it some place to make it clear for you. Okay, if theta is negative coefficient, it means there is no leverages effect. So what is the leverage effect? Take the following. Bad news has more impact on volatility than good news. Volatility is higher in falling market than in a rising market. Non-trading period effect. When market is closed, information ceases to accumulate at different rate to when it is open. And this is the interpretation of the formula, as you can see it here. Now we apply the model and then we explain it in more detail. Okay, so in ARCH I'll go to eViews, as you can see it here. Let me just minimize it. I'll go to eViews. Okay, this is eViews. I'll go to estimate, and here we can see that for the EGARCH model with the logarithm, we can apply it to estimate and equation here. Okay. Now this is, we leave this one as it is, as you can see it. We are not going to change any, because this is the formula we used even in the previous models. So what we have here, okay, now we'll go to EGARCH, which is exponential, and then we'll go to leave everything as it is here. and then we press OK. To see this model here, okay, the same here, we have to use the eViews legacy, and then we have to find the outcome. This is the outcome for exponential GARCH EGARCH model. As you can see it here, this is log for GARCH, this is constant, this is the absolute value, residual lag 1 multiplied by square GARCH lag 1, and here the residual lag 1 at square GARCH lag 1, and this is what we have to interpret here. Let me show you this part here first, and I'll assign all these outcome to the formula. Okay, sorry. Yes, I want to move it, make some space to make it clear for you. Okay. Okay, this is the exponential equation, and this is the outcome. As you can see it here, this is log 1, log the independent variable. This is C1, C2, C3, C4, C5. C5 is constant. C6 is the absolute, which is this part. This is C5. This is C5, C6, C7, and C8. As you can see it here, C5, this one part here, which is alpha, constant. C6, the GARCH term, lag 1 square, which is C6 GARCH term. Where is it? This is GARCH, log GARCH term. This one here, GARCH term. C6, as you can see it here, this is C6 here for the absolute. So this is the value of beta 2. This is the value of beta 2, C6, 0.084, which is positive and statistically significant. And here C7, as you can see it here, C7 is residual minus 1 divided by absolute. This is the part here, negative and statistically significant. And C6, C7, negative, C8, and this is C8. As you can, sorry, C8 is GARCH, which is this part here. Okay, let me say it again to make it more clear. C5, 6, 7, 8. C5, C5, constant. C6, as you can see it here, the absolute. This is C6 here, which is positive and statistically significant. C7, residual, lag 1 at divided by square GARCH, which is this part here. This is GARCH. This is absolute, which is C6, and this is the squared GARCH. Residual lag 1 divided by square GARCH lag 1. And here C8, as you can see it here, C8, the GARCH lag 1 square, C8. This is C8 here, in this part here, lag beta 1, mean positive, 0.991, statistically significant. C7 here, this part theta, C7, negative and statistically significant. C6, the absolute, beta 2, this is the C6, which is positive and statistically significant, and the other one, the constant here. So what does it mean now? Just we replace it in the equation or in the model we used. So here we have now this part here, log sigma lag 1 square, log sigma lag 1 square represent GARCH term. And beta 2, as you can see it here, the absolute represent 0.0844, this part here. And p-value less than 5%, which is significant, statistically significant here. C6, statistically significant at 1% level, and this means that the shock has significant impact on volatility. And then theta, we'll go to theta. This is the square residual lag 1 divided by the GARCH or variance lag 1, which is minus, as you can see it here, minus 0.0437, which is statistically significant. And this means that when p-value less than 5% or less than significant at 5% or 1% level, this with negative sign means if the error term increase the volatility, which is number 7, which is this part here, just to make it clear. And this part here, we are talking about this part here. This means that negative 0.0437 were statistically significant because p-value less than 5%. This means that this with negative sign means if error term increase the volatility, if the error term decrease, the volatility increases. There is inverse relation between the error term and volatility. The error term and volatility, E and sigma, which is here E, as you can see it, and sigma square at the present time. The inverse relationship means if the error increase, mean a good news, the volatility decrease. In other words, positive news will lead to decrease volatility. I repeat it again for this term here, and this is C7, negative 0.0437 and statistically significant. Here, when p-value is significant at 1% level, this with negative sign means if error term increase, the volatility decrease, which is inverse relationship between the error term and volatility. So the inverse relation means if error increase and good news, the volatility decrease. In other words, positive news will lead to a decrease in volatility. Now this term here for GARCH, sigma log sigma square lag 1, which is, we call it as here C8, as you can see it here in the equation. This is C8, positive 0.991 and statistically significant. This is the level. This means the volatility persistence is very high, means if the market volatile, it will be change very high. It means the market remain volatile for many days. And this one again, if we go back to this term here for theta, you can see it if the effect of C7 is negative, as we find it is negative coefficient, it means there is no leverage effect. Then we can easily go and apply multivariate or MGARCH model. Okay, this is the simple explanation for the EGARCH model. Now the multivariate model, you can see the model here. This is the model, which is simply easy return, and here you can say alpha, beta, yt minus 1, beta, residual lag 1, and then beta 3 variance lag 1 square. And this is MGARCH model, and the main thing in this MGARCH model, we are going to talk about the effect of beta 3 on R. So in this case, if beta 3 there is impact, I mean, to see, just we want to see whether beta 3 has an impact on the variance variance or volatility on the return significantly or not. The answer that if p-value is greater than 5%, so there is no significant relation between the variance and the return, which means that if p-value less than 5%, there is a relation between variance and return. But if p-value is greater than 5%, there is no relation between beta 3 and the return. Let me just put it in the system. We have two methods to use it in this system. There is another equation we can use the system, but now we use this equation or this formula. I'll go to estimate, and then I'll go to, as you can see it here, the equation, and here we can put variance. Okay, because here we don't use, we want to see the GARCH effect, positive or negative, which is beta 3. As we mentioned, we put variance, and here we leave it as it is, as you can see it here. EGARCH, leave everything as it is, and just change the arch M to, you can put it from none to standard deviation or log or variance. We put variance and then leave everything as it is, then press OK. Then you can see the outcome here. If you look to this equation here, you can see this is GARCH. One is not significant, and this one here, beta 2, which is GARCH, as you can see it here from the outcome, is not significant, which is positive, the coefficient positive, and statistically not significant because p-value 35.38, which is greater than 5%. So what does it mean here? Because we are looking about this model, whether we want to see, as before, we want to see whether there is impact on the variance of volatility, which is here in the equation, as you can see it. There is any impact of BA3 or the variance of lag 1 square on return or not. If the hypothesis, if null hypothesis, if p-value of BA3 of GARCH not less than 5%, there is impact on the return. But if the p-value of beta 3 for GARCH greater than 5%, it means that we accept the null hypothesis and reject the alternative, which means that there is no impact from GARCH lag 1 square to the return. And here there is no significant relation between the variance and the return. This is we called MGARCH model. And there is another way we can use it, but I'm going to post it later on in the next week, and we'll see we can apply these two equations as a systematical equation, and then we can find the result whether there is the GARCH impact on the return or not. Thank you so much.